Welcome back, everybody. In this video, we're going to do another example of a number problem, and then we'll go on to work on some percent problems. So this one actually not really a number problem, more just kind of regular story problem. It says the average cost of a car in 2014 was $28,400. This was $1,600 less than 6 times the cost in 1975. And then next sentence, what was the average cost of a car in 1975? So the second sentence is telling us what we are looking for, which is the cost in 1975. Okay, and so that will make that our variable. I'm going to use X for this. Notice that it's a good idea to be specific about this. If I had just said X is the cost, that's not specific enough because we need to know, well, which cost, the cost in 2014 or the cost in 1975. We actually want to know the cost in 1975. Okay, and that's what we're looking for. And basically that's all we get out of that second sentence. Okay, then the first part says the average cost of a car in 2014 was $28,400. And then this, that's the 28,400 was, that's past tense of is, so that's where our equal sign is going to go. $1,600 less than 6 times the cost in 1975. So the 28,400 was $1,600 less than 6 times the cost in 1975. We can bring that closer. So $1,600 less than the cost, 6 times the cost in 1975. So this is the equation we get out of it. Notice that the less than is going to translate as a subtraction. That's not the same thing as saying is less than, which is that relational operator, the less than symbol. Less than just translates here as a subtraction. So the 28,400 is $1,600 less than 6 times the cost in 1975. Also notice that the order that it is appearing in the equation is different from the word order in the sentence. In the sentence, it says $28,400 is or equals 6 times X minus 1,600. The 1,600 is mentioned last. Here, the 1,600 is mentioned before the 6 times cost in 1975. Okay, also you'll notice really that the 2014 and 1975 are not exactly used in the calculations. Okay, so there's that. So then that's the setup. So then our next task will be to solve this equation. We're going to do that by adding first 1,600 to both sides. And that will still be 6x. So our 28,400 plus 1,600, we'll do that on my scratch paper. So this will be 30,000, right? And that is our 6x. Dividing through by 6, it will be 5,000. Seems pretty cheap, but then that was a long time ago. So the average cost for a car in 1975 was $5,000, it looks like. All right, so that's the end of that example. For the next part, we're going to start working on some examples involving percentages. So I'm going to assume that already you're comfortable with working with percents, that is changing from a percent to a decimal and back again, changing 25% into 1/4 and so on. The first type of problems that we'll deal with are, I'm just calling them percent problems here, are where we have 3 numbers involved. There's a whole amount, a size of it, the whole amount, and then a size of a part, and then the percentage that relates the two. So for example, we know that 9 is 25% of 36. If you take 36 and divide it into 4 parts, that's 36. There is 4 nines make up 36, and 100% is 100%. And so each of those parts is 25%. 9 is 25% of 36. So the kinds of questions that you may see related to this are, we've got these 3 numbers. So we have to tell you 2 of them, and we can ask you the third one. So for example, we may have What number is 25% of 36? In this case, the size of the part is unknown. Or 9 is some percentage of 36, in which case we know the size of the part and the size of the whole, but the percentage is unknown. Or we may have 9 is 25% of what amount, in which case the part and the percent are known, but the size of the whole thing is unknown. So either way, we have to tell you two numbers, and we can ask you what the third one is. Do you know, are you looking for the size of the piece, the size of the whole, or are you looking for the percentage? Okay, so all of these kinds of questions fit into one of those categories. So as an example, we would like to know, what is 18% of 60? So to answer this question, what will translate as our variable? What is our unknown? We'll make that n. Is our equal sign. 18%, when you're working with these, you want to turn the percentages into decimals or fractions right away. So 18% is 0.18. And so we'll have of means multiplication. And so we'll have 0.18 times 60. Okay, and that will be our n. So let me calculate that. Looks like it's 10.8. Okay, and that number, 10.8, is 18% of 60. Okay, so we'll have another example next. All right, in the next example, it says 12 is 15% of what number? Again, we have the percentage, we have the 12. 12 is the part, we don't know the size of the whole in this case. So we'll translate it as follows. 12 is like equals, 15% is 0.15. And then of what number? Of is like multiplication. And then our what number is going to, again, translate as our variable. So 12 is 0.15 times n. So then to solve, we can divide both sides by the 0.15. And that will serve to isolate the n for us. So 12 divided by 0.15 is our n. So that looks like 80. Okay, 80. So 80, 12 is 15% of 80. Okay, next up, 3,000 is what percent of 50,000? In this case, the percentage is not known, but we'll still translate it kind of in the same way as we've done the others. So 3,000 is, and then I'm going to make, and I'm just going to use n for this, of, and then our 50,000. So then to solve this, we're going to isolate our n by dividing both sides by 50,000. Okay, it's not too many zeros. And then we want to divide here the numerator and denominator by 1,000. That will eliminate 3 zeros for us. So our n is 3 over 50. And so we need to turn that into a percentage. The question is asking us what percent that is. So rather than doing a long division here to make it into a decimal, 50 divides evenly into 100. So it's cleanest to just multiply the top and bottom by 2. That will give you 6 100ths. 3/50ths is the same as 6 100ths. And 6 100ths is 6%. So 3,000 is 6% of 50,000. Okay. So next we're going to do a story problem, kind of like the problems we were just doing, but there's a story wrapped around it. Remember for each of these that you're given the part, the whole, or the percentage, and one other value, and you're asked for either the part, the whole, or the percentage. This one, like I said, it's just got a story that goes with it. So here it says, one serving of a particular brand of cereal has 7 grams of fiber, which is 28% of the recommended daily amount. So we want to know, what is that recommended daily amount of fiber? So the percentage is here, that's the 28%, and then that is the percentage. Then you have to ask yourself, is the 7 grams of fiber, is that the whole, or is that the part, that 28% of some larger unknown amount? And reading through the question, this is the part of the whole amount. So translating this, the 7 is 28% of the whole amount. The 7 grams of fiber in one serving is, that's our equal sign, 28% of the entire amount. Okay, so then once again, we will divide by 0.28, and that will make it so that our N is isolated. So let's do that. And that's 25. All right, so there's 25 grams of fiber is the recommended daily amount. Okay. All right, so again, here we were given the size of the part and the percentage, and we wanted to find the whole. Okay, moving on. Still working on percentages, we want to look at the idea of percentage change. So quantities change, and sometimes it makes most sense to express those changes as percentages. And that's what this is about. So for example, suppose that Edith lost 4 pounds. Is that a little or is it a lot? Well, if Edith weighed 140 pounds before and now she weighs 136, that's not a huge amount. If, on the other hand, she was a kid that weighed 20 pounds before and now she weighs 16, that's going to be a bigger difference. That 4 pounds is a bigger percentage of the 20 pounds she weighed in the first place than if it were a 140-pound adult. Another example, suppose that Nancy got a $3,000 raise at her job. Is that good? Anybody could use $3,000 more, of course. If she made $12,000 in the first place and now she makes $15,000, then that's a pretty significant change. She's going to notice that in her budget and in her lifestyle. On the other hand, if Nancy was an anesthesiologist making $300,000 a year, and now she makes $303,000 a year, she may not even notice that extra $3,000 because that $3,000 would be such a small percentage of what her existing income was. So the takeaway here is that $3,000 or the 4 pounds could be a little or it could be a lot of increase depending on what the starting amount was. And that's why we express change sometimes as percentages. So let's see a formula for that. So the way that I like to express percentage change is as follows. It's a percent, so you can write it as a fraction as well. Whatever the amount was now or is now minus what it used to be divided by what it used to be. That's the percentage change. If it comes out negative, that would represent a decrease. If it comes out positive, that would represent an increase. So as an example, we'll go ahead and use Edith for the first one. Suppose that Edith weighed, let's just keep it easy. Let's say that she weighed 48 pounds in the first place and she decreased down to 44 pounds. Okay, so she's a kid, she lost 4 pounds. All right, so then the percentage change would be what she is now, 44 pounds, minus what she was, which would be 48 pounds, divided by what she used to weigh. And this is important. You want to make sure that it is the former amount, not the current amount. She used to weigh 48 pounds. Okay, so that's a decrease of 4 out of 48. And if you simplify that, that's negative 1/16. And we can turn that into a decimal. That will be negative 0.0625. I think. And then turning that into a percentage, that's negative 6.25%. So she lost about 6.25% of her body weight. Okay, let's take Nancy and her raise now. So let's say that Nancy made $51,000 before, and they raised her up to make $54,000. Okay, so that's a $3,000 raise. What percentage increase did they give her? So what she makes now, which is the $54,000, minus what she makes before, which was $51,000, divided by the $51,000. So that was the $3,000 increase expressed as a percentage of the original amount. And then we can get a decimal for that. And that is about 0.058. Let's call that 0.059 as a decimal. I've rounded there, okay? That would be 5.9%. Okay, so expressing those changes as a percentage can make them more meaningful. And a way to think about it is just whatever it is now minus whatever it used to be divided by whatever it used to be. And then if it's negative, that represents a decrease. If it's positive, that represents an increase. Okay, so let's try some examples. So here we're told that the population of a small town increased from 4,460 to 4,594 in the last decade. We want to find the percentage change rounded to the nearest whole number. So it increased. So what it is now, 4,594 minus what it was divided by what it was. So let's compute that. That's a increase of 134 people. And that is about 3%. Okay, I divided there, I got 0.03, I turned that into 3%. Okay, so the population increased by 3% in that 10 years. Okay, here's another example. A grilled chicken club sandwich has 22 grams of fat. The restaurant that makes these sandwiches, let's say they introduce a new light version of the sandwich that has only 15 grams of fat. We would like to know the percentage decrease that you would get by switching from the regular to the light version of that sandwich. So what it is now, or what the new version of the sandwich would be 15 grams of fat. What it was before was 22 grams, and then what it was before was again 22 grams. So that's a decrease of 7 grams of fat, and it was originally 22. And that's about 31.8%. So 31.8%. And that was negative, so it decreased by about almost 32%. Okay, so a couple of percentage change problems. We'll do one more. Suppose that a jacket was originally $80. It goes on sale for 20% off. That's called the discount rate, the 20% off. That's the discount rate. We want to know the amount of the discount. That's the dollar amount that you're saving, and then what the sale price is. Okay, so the discount is 20%, and that's this one is going to be easiest actually to not use the formula for this. So we want to find the discount of 20% from the $80. So we need to actually ask ourselves, what is 20% of 80? Okay, and we had done that. So what is 20% of 80? 20% of 80 will be 16. That's the dollar amount of discount you are saving. And then the sale price will be the 80 minus the 16. So that is $64, the sale price. If we had tried to do this using that percentage change formula, it would look like this. We had a decrease of 20%. And so we wanted to know the sale price, so that's unknown, that would be our variable. What it is now minus what it was divided by what it was. Okay, so this would be the equation. If you take and solve this for x, you're going to get negative 0.20 times 80 plus 80. That will be our x. The 20% of 80 was the 16 that got subtracted from 80, giving us that $64. Okay, so the amount of discount was $16, the sale price $64. Okay, going the other direction from a sale would be the idea of a markup. So a store owner orders some flower pots at an original cost of $4 each. So the wholesaler or supplier sells them to the store at $4 each. Of course, the store owner is not going to turn around and sell them for $4 because he or she needs to make a profit on them. So the owner is going to mark them up by 30%. So we need to find the amount of the markup and then what's called the list price. The list price is the amount that these pots will actually sell for. So we need to first figure out the amount of profit or markup the owner is going to build into the cost of these pots. So we need to know what's 30% of $4. Okay, so what is 30% of $4? So 3 times 4 is 12. That will be $1.20. So the markup on them is going to be $1.20. And so then the list price will be the $4 plus the $1.20, which is $5.20. Okay, all right, that takes care of that. So in this video, we've gone over a couple of examples involving just solving for unknown quantities. We looked at some percentages where we had a whole, a part, and a percentage that related the two. And then we also did some percentage change where we looked at amounts increasing or decreasing and saw that expressing these amounts of change as a percentage can make them a little bit more meaningful. Okay, if you have any questions on this, let me know. And in the meantime, have a great day.